Hello, Sauce here. I'm going to provide some examples of simplifying by factoring and canceling. Factor and cancel is what we're going to do. It's our strategy to take something like this and simplify it. Simplify means to rewrite it in simpler terms. And this is not so simple. We have a fraction or a quotient, 12 plus 8x in the numerator and 4 in the denominator. So how could I go about this? One choice is factor and cancel. What do I mean by that? Well, I'm going to think of a number that divides 12 and 8x and factor that out. When we factor something out, in this case a 2, because 12 is divisible by 2 and 8x is divisible by 2, then I write what I'm going to factor out outside, and what remains of my two terms is going to be inside parentheses. So what remains after I divide 12 by 2? 6. And what remains of 8x when I divide 8x by 2? 4x. And it's positive because I was adding. So I factored a 2 out of the numerator. What I'm going to do is I'm going to show 4 in factored form. That means that I'm going to separate 4 into two factors that when multiplied equal 4, and I've found that to be 2 times 2. I've factored the same thing from both the numerator and denominator, and the reason why we would do that is because we can now cancel common factors. They become 1 and they can be ignored. So after factoring and canceling the 2, I have 6 plus 4x just still being divided by this 2 that remains. And I'm not finished simplifying until I can do everything possible. I can factor and cancel again because I can see that a 2 divides 6 and a 2 divides 4x. And when I factor out a 2, it'll be a common factor with this one in the denominator, and I'll be able to cancel it as well. Let me go through that process. Factoring out a 2 means I'm going to write the 2 outside of parentheses, and what remains of the 6 when I divide it by 2 is 3. What remains of the 4x after I've factored out a 2 is the 2x. Because this is addition, that 2x is positive, and I'm still dividing by 2. These cancel, and this leaves 3 plus 2x. I'm finished because I can't simplify further. I started with something that was reasonably complicated, and factoring and canceling made it simpler. Let's do that with a couple more examples. I'm going to be a little quicker in these examples, but they're going to get a little more complicated. 7x minus 3x squared over 2x. I'm looking for this numerator to be factored. I'm not going to factor out a number because 7 and 3 can't be divided by a number, both can't be divided by a number evenly. But I can see that both of these terms in the numerator have an x as a common factor. I'm going to factor out an x. What remains of the 7x is 7. And what remains of the negative 3x squared is the negative 3 and one of the x's. Remember, x squared means x times x. So when we factor out an x from x squared, one x remains, and the other one is shown as what we factored out. The numerator was a 2 times x, and the x is the common factor that I can cancel, leaving in this case the 7 minus 3x and then the 2 in the denominator. If I wanted to go further in simplifying, then I would want to make sure that I can't factor out a 2 from these from the numerator, from the 2 terms in the numerator, and cancel it. That can't be done. 2 does not divide 7, and it does not divide 3. Let's give another example. 16t plus 36 divided by 24. I'm going to factor and cancel. What divides 16 and 36? 2 does, but I'm going to choose a higher number that divides both 16 and 36. 8 divides 16, but does 8 divide 36? It doesn't. 9 goes into 36 4 times, but 8 doesn't divide it evenly. What about 4? 4 divides 16, and 4 divides 36. So rather than choosing to factor out a 2, I'm going to go for a higher number. I'm going to factor out a 4. What remains of the 16t is 4t. Remember that we can check by remultiplying. 4 times 4t equals 16t. That's why I can factor out a 4 and the 4t remains. What remains of 36 when I've factored out the 4? 4 times 9 equals 36, so the 9 remains. And in the denominator, if I want to cancel, then I'm going to try to factor out a 4 from 24. That can be done because 24 can be thought of as 4 times 6. Notice that in this first example, I could have, instead of factoring out a 2 and a 2 again, I could have gone this route and factored out the higher number 4 in one step. I didn't do that because I wanted to show the process of repeatedly factoring something out. Let's finish with this example. We have a common factor 4. What remains is the 4t plus 9 divided by 6. And if I can go further, I need to go further to simplify. I'm going to look for something that divides the 4t and the 9 and the 6. I'm thinking 2, but 2 doesn't divide these. 3 divides 9 and 6, but not 4. I can't find anything. I can't simplify further. I have to stop there.